Hey guys, today we're going to have a look at Assessment 9, which is solving quadratics by any algebraic method. If this is your first time through this assessment, make sure you hit pause and work through the questions on your own first, and then watch us take it up at the end. If you are struggling with any of these topics, make sure you have a look at the links down below for the lessons we've done on them. Right, let's get started. First, I want you to figure out which of these quadratics cannot be solved. Giving you a hint here, use the discriminant. Question 2, you need to decide which of these methods would be the easiest one to work out the solutions to these quadratics. Question 3, I want you to solve these quadratics by whatever method you choose. And question 4, I want you to complete the squares, and once you've completed the square, you should rearrange to solve. I hope you've had a chance to get through that on your own. Let's start taking it up. Question 1, deciding which of these quadratics cannot be solved, we've got to keep in mind the discriminant. Remember the quadratic formula? It will give you two possible answers. One when you add the square root of this expression, and one when you subtract the square root of this expression. But if this expression, b squared minus 4ac, is negative, its value cannot be square rooted. So that's our big hint. The discriminant must not be negative, or there will be no solutions. So we're looking out for which of these quadratics has a negative discriminant. And looking at the first question, which is already set out in the x squared plus bx plus c equals 0 format. A is 1, b is 5, and c is 2. Let's substitute that into the discriminant to see if it's positive, negative, or 0. So I've substituted into the discriminant, and I'm simplifying, and I get an answer of 17. That is not the answer for x. That is just the discriminant, and I see that it's positive, which means I can square root it, so I can solve this quadratic. Let's check question B. Now, first of all, it wasn't in the correct format. I needed it to be a quadratic equal to 0, so I've moved my x from the right side over to the left side, making it negative. So I've got a is 7, b is negative 1, and c is 3. Let's substitute that into the expression for the discriminant. And simplifying that and solving that, I get negative 83. Remember what we said before? We cannot square root a negative number. So this is the quadratic that cannot be solved. But let's just make sure it's the only one that can't be solved. So let's have a look at C. Now C wasn't in the correct format yet either. I needed it to be equal to 0, so I started by taking the 7 from the right-hand side. It was positive, so I subtracted it off from the left-hand side. So I now see that A is 2, B is 9, and C is negative 7. Let's substitute that into the discriminant. And we will simplify that. And solving 137. Again, that's not my solution to the quadratic. That is just to show me the discriminant is a positive number. We can square root 137 in the formula, and we will get two different answers, once when we add, once when we subtract. So C can be solved. I notice that D is not in the correct format yet because it's not equal to 0. So my first step is to take the 5x over to the left-hand side. It was positive. I've made it negative. So I see that A is 3, B is negative 5, and C is positive 2. Substituting that into the discriminant expression and simplifying and solving gives me positive 49. I can definitely square root positive 49. I definitely know this is going to give me a solution. So the one quadratic that cannot be solved is quadratic B. Next, we want to match up these quadratics with the best method used for solving it. Now, looking at question number 1, I see this quadratic has got a number in front of the x squared term, which means it's not the easiest quadratic to solve. I could try and factorize, but I would need to either factor out that 2 or split the middle term. So I'm going to try splitting the middle term and see if that will be possible. Remember, we do the first term, the a value, multiplied by the last term, the c value. 2 times negative 15 is negative 30. And thinking of two numbers which multiply to make negative 30, but add to make positive 7, I came up with positive 10 and negative 3. So I can split that middle term. I'm going to turn 7x into 10x minus 3x. And by splitting that middle term, I can factorize by parts. The first two terms have 2x as a common factor, and the last two terms have 3 as a common factor. Sorry, negative 3 as a common factor. So factoring that out, I see that my two sets of brackets are exactly the same, which means I can regroup, which means I have factorized by splitting the middle term. So the best method for solving this quadratic would be splitting the middle term. Question 2, if you look at it closely, I've got x plus 4 times x plus 4, a bracket multiplied by itself. I could have just written that as x plus 4 squared. And it doesn't matter that I've got 7 on the other side of that equation, because when I complete the square, I'm actually going to be able to get x on its own. So, completing the square, it's already done there for me. I can solve that by doing plus or minus the square root of 7, and then just subtracting 4 for it. So question 2 is definitely a completing the square option. Question 3, I've got a quadratic there. There is no number in front of the x squared term, so it looks like it will be an easy one to factorize. But let's think about this. Let's try. What numbers multiply to make negative 8 and add to make positive 4? I'm thinking, what numbers multiply to make negative 8? It's got to be a positive and a negative. And they need to add to make a positive, so the bigger number should be the positive one. The only factors of 8 I can think of are 1 and 8 and 2 and 4. And making the bigger number positive, negative 1 plus 8 would be 7, not 4. And negative 2 plus 4 would make positive 2, not 4. So I can't think of what those two numbers will be. I can't factorize. So we're going to have to use the formula. And the last one must be factorizing, but let's just check to make sure. There's no number in front of the x squared term, so there's no need for me to split the middle term. Let's just think of what are the two numbers that multiply to make negative 32 and add to make negative 4. To make negative 32, I can think maybe 8 and 4, making the bigger number negative so that the sum will be negative. Negative 8 plus 4 does make negative 4. So as you see, I've factorized that quite quickly. No need to use the formula. Question 4, we can do by factorizing. Next question. Question 1, I can see it's going to be quite a tricky one because I've got a number in front of the x squared and I can't factor that number out. I'm thinking about splitting the middle term, but I'm thinking about what numbers multiply to make 6 times negative 20, so negative 120, and add to make negative 7. And nothing's coming to mind. So for question A, I'm going to use the formula. I can see that A is 6, B is negative 7, and C is negative 20. 6, negative 7, negative 20. So substitute that into the formula. Simplify the formula. And solve twice. Once when I'm going to do 7 plus the square root of 529 over 12, and once when I'm going to do 7 minus the square root of 529 over 12. My two answers, and I didn't have to round that first one, it was exactly 2.5, and the second one was negative 1.3 recurring. Rounding to 3 significant figures where necessary. In this case, it was necessary to round to 3 significant figures. In this case, it was not rounded, it was exact. So my two answers are 2.5 and negative 1.3 recurring, or negative 1.33. Question B, again looking at this first, I'm thinking, can I factorize? Can I think of two numbers that multiply to make negative 21 and add to make negative 4? I'm thinking negative 7 and 3. So I've got my factorized quadratic. I'm not going to waste time with the formula. It was nice and quick and easy. But my answers are not negative 7 and positive 3. I need to solve this quadratic by setting each bracket equal to 0. So x minus 7 equals 0, or x plus 3 equals 0. In the case of x minus 7, to get x on its own, I take the 7 to the other side and I add it, so x is equal to 7. In the case of x plus 3, I get the x on its own, I take the 3 to the other side and subtract it, so x is negative 3. So there are my two answers, 7 and negative 3. Question C, like before, I hope you notice that I've already pretty much completed that square for you. You just need to rearrange to solve. Don't try expanding that out, rearranging it, and using the formula. That's long, tedious, and messy. So let's go ahead and solve this by completing the square. First thing I wanted to get rid of is the square. So the opposite of square is square root. And remember, when you square root a value, there are two possible answers. One when you add the answer, and one when you subtract. Then to get x on its own, I'm going to subtract that positive 3 to the other side. So I have x equals negative 3 plus or minus the square root of 8. Now, very often I get you to put the negative 3 after the term that's already there, but I don't want to make the mistake of doing the square root of 8 minus 3, so the square root of 5. The negative 3 is not under that square root sign. So our two possible answers, once when we add and once when we subtract, are negative 0.172 and negative 5.83. Both of these values are rounded to 3 significant figures. Question D. Again, I'm looking at this quadratic. I see there's no number in front of the x squared term, so there's no need to split the middle term. But can I think of two numbers that multiply to make negative 21 and add to make negative 1? I can't think of anything. So again, I'm going to use the formula. Okay, so I know that A is 1, B is negative 1, and C is negative 20. So I'll substitute that into the formula. I will simplify that formula. And I'll go ahead and solve. Once when I'm going to add the square root of 85, and once when I'm going to subtract the square root of 85. My two answers are 5.11 and negative 4.11. Be careful with your rounding on this question. They're both the 3 significant figures. Question 4, completing the square to solve. So first I get you to complete the square, and I hope you remember the rule. To find the number that's inside the brackets, we're going to half the b term. So I've got half of negative 4 is negative 2. Remember, I do want that negative 20 outside of the brackets, but what I don't want is the result of squaring what I've got inside the brackets. So I've got minus 20 minus 4 equals 0. That's going to be negative 2 for P, negative 24 for Q. And my answers, I need to rearrange this to get x on its own. So I'll take the 24 to the other side. It's minus now, so I'll make it plus. I'll get rid of the square by square rooting. Don't forget a positive and negative for that. Positive and negative square root of 24. And I'll get the x on its own by taking that negative 2 to the other side, making it positive. So my two answers, once when I add, once when I subtract, is 6.90 and negative 2.90. Be careful with how you round. That was correctly rounded to 3 significant figures. The 0 was a placeholder in between significant figures. Question B. First of all, it's not in the right format. It's not equal to 0. So I'm completing the square, still halving the b term, which is half of 2, 1. And I want the 2 that is outside of the brackets, but I do not want the value inside the bracket squared, so take away the 1. And I've taken the 4, which was on the other side, over to the left-hand side to leave it equal to 0. I've got x plus 1 squared, and 2 minus 1 minus 4 gives us negative 3, equals 0. So P is 1, and Q is negative 3. Rearranging to solve, take that 3 to the other side. It was minus, and now it's plus. Get rid of that square, so square root. Don't forget we want plus and minus. And get rid of that 1. It's positive, so let's make it negative. X equals negative 1 plus or minus the square root of 3. Work out your two answers for that. That's going to be 0.732 and negative 2.73. They are both rounded to 3 significant figures even though that is to different place values. Question C, again, is not in the correct format to begin with. I wanted it to be a completed square equal to 0, so I started by looking at the b term and halving that, put that inside the bracket. I definitely want that -4 term outside of the bracket, but what I do not want is the value inside the bracket squared, so subtract 16. And the -7 that was on the right-hand side, I've brought it over to the left-hand side, making it +7, so that I have it equal to 0. So inside the bracket, I've got -4, and outside the bracket, -4 minus 16 plus 7 gives me -13. P is -4, and Q is -13. Again, to solve, let's get x on its own. First, we'll get rid of the -13, making it positive on the other side. Then we'll get rid of the square sign, square rooting, remember plus and minus square root. And then we'll get the x on its own, moving the -4 to the other side, making it positive. So +4 plus or minus the square root of 13, our two answers are 7.61 and 0.394. Again, both values to 3 significant figures. Now, I hope that you found this practice and these explanations helpful. And again, if you found yourself a bit lost, have a look at the links down below and make sure you go back and check out those lessons. Keep practicing, guys. Quadratics is a huge part of GCSE. Good luck.